Hello everyone, let's do a problem of fluid mechanics. Right, the problem is written here. Find the coefficient of friction of the surface on which a vessel is placed when water flows out from a vessel small pipe at the bottom just to prevent sliding. Given area of cross section of the vessel is capital A, that of the pipe is small a, and the density of water is taken as rho here. Here the vessel filled with water up to the height h. There is a small pipe having cross sectional area small a from which the water flows out. Alright, first of all, why this vessel should slide on this ground? Right? We want to know its coefficient of friction. This is because when this water is moving out, there is outward thrust, right? Outward force, because the momentum is changing. Whenever something is moving, there is change in the momentum, right? So because of that, a force arises. That force will push back this vessel on the ground, which will cause sliding. But if the friction is sufficient, it will not slide. So that's what we want to know. What is the coefficient of friction that the vessel does not slide when water flows out? Let us see what is the outward thrust here. First, let us keep here what is the velocity of efflux. You must have learned that the velocity of efflux is under root 2 gh. This is called Torricelli's law. That is, the efflux velocity of a fluid from a vessel is always given by under root 2 gh, where h is what? At what depth you have made the hole, right? Let's see now what is the outward thrust here. So the force is given by dp by dt, that is Newton's second law. Let us further simplify this. D by dt of m into v, mass of the water, which is changing per second. So I bring this v out because velocity is fixed here, which is called efflux velocity. So that's a constant. So dm by dt, which can further be written as d by dt of mass can be written density into volume. See this, let us say x distance this water moves in this outlet. From here to here, say x, it can be different also, right? So we can say density into volume. Volume of this small pipe, you can assume this area of cross section is small a here. Area of cross section into the length of that pipe x will give me the volume. So this gives me mass. Let us bring out rho, which is constant, a also is constant, dx by dt. Dx by dt is again velocity of that water, so which can be written as v into rho into a into velocity, which further simplifies to rho area of cross section and velocity square. So I got the force, outward thrust. It should be balanced with the frictional force, right? So therefore frictional force, which is mu mg, is equal to rho a into v square. Mu mg, m is the mass of this water of column height h. So we can change that as density of water, volume of water. Cross sectional area into height will give me volume. So this becomes the frictional force. Rho a, this v square I can write 2gh, square of the efflux velocity. So mu is equal to, from here everything cancels there, 2 small a divided by capital A. This is the minimum coefficient of friction required. So in the question they can give you actually numerical values of these things. They can give you radius of this, you can find pi r square from there. They can give you radius of this vessel, cylindrical vessel, and then you can put in that or they can directly give you cross-sectional area as numbers. So you can create formula first like this and then substitute in this the values. Obviously it will not have any dimensions. Small a also is areas, big A is also area, so no dimension for this one, coefficient of friction. I hope you understood this. If you want, you can comment, and if you are interested in any other topic, please write in comment.